series. If you guys are joining us with Zoom, just kind of want to walk through a few options. If you are joining, there's an option to join your audio by two formats, either by a phone call, which is a dial-in number, or by your computer audio. Then as Dr. N.T. Crosby begins the presentation here in a few minutes, if you have any questions and you're joining from your Zoom app on a mobile device, please feel free to click more in the bottom right-hand side. A box will pop up, click the chat, and that will drop those questions into our chat room that we will be monitoring. If you're joining via computer, the chat is at the very bottom. You would click the chat, drop those questions in there. And then if you're joining us tonight with our Facebook live stream, please feel free to drop any questions into the comment box. So if you guys don't mind, drop in, let us know where you're joining us tonight. Jennifer is located down in Waldron, Arkansas. I am located in Broken Arrow, Oklahoma. And Dr. N.T. Crosby is joining us tonight from Mexico, Missouri. So just to kind of kick it off tonight, we're going to kind of start tonight with a little bit of polls to kind of kick the program off. When we think about the ruminant, you know that ruminant is a great upcycler for us. One of the questions that we've got tonight is, out of the four compartments in the ruminant, which is considered to be the true stomach? Omasum, abomasum, or the reticulum? If you are joining us on Zoom, you should be able to select one of those questions. Which type? The second question is, which type of rumen microbe prefers a pH above 6.2%? And our options is fiber digesting or starch digesting. And then our third question is, blank rumen papillae equals blank nutrient absorption. And our option is less rumen papillae equals better ruminant absorption. More rumen papillae equals less nutrient absorption. Or the third choice is more rumen papillae equals better nutrient absorption. So we're going to leave that up for just a few seconds. Tonight, we appreciate Dr. N.T. Crosby joining on and taking the time out of his evening to talk with us tonight. I'm going to end this polling. For those of you that are streaming on Facebook, feel free to drop those questions. If you want to answer any of those, please drop that in there. So with that, I have ended that polling, and I'm going to turn it over to Dr. N.T. Crosby.
Good evening, everyone. Glad to be here, and thank you for joining us. This evening, what we'll do a little bit of is kind of go through what I'll call the remarkable ruminant. So what is unique about this animal when we think about the ruminant is, as you look at those pictures at the top, that animal, our cows can survive when the grass is really good to marginal, and then in some cases they are able to utilize that tough fibrous forage there to the right. But what's really important to me when we think about a ruminant is we have a lot of people outside of our industry telling us that plant-based foods and things like that are what's going to feed the world, but I'd refer those folks to that picture there on the other side of the screen, and that's a picture I took in southern New Mexico. And I would dare to say that we're not going to grow too many corn or beans or carrots on that patch of rock, but yet that cow can go out there and harvest that forage and produce beef for us and our world to eat. So really cows are remarkable, and I am very fortunate, I feel like, as a nutritionist to get to work with our ruminant species. So tonight we'll kind of use a combination of a few data slides and some videos to try and walk through the ruminant digestive system. And this will really serve as a baseline for the cattle chats to continue throughout our late summer and fall season with the Farmers Co-op. And I'm having trouble advancing my slides, so just one moment. All right, so with when we think about the ruminant digestive tract, we probably don't think of the esophagus too much, but obviously that's the route from the mouth to the rumen of the animal. We probably don't think about the esophagus until it gets blocked. And if you've ever had a cow that has had an esophagus blocked, maybe by a hedge apple, or I've actually seen it in places where we fed whole potatoes to cows, they'll get a blockage, and what it'll typically cause is bloat, because that rumen will produce gas. And of course, when the cow belches, she brings up that gas as well as her cud that she's going to chew, as we'll talk about. That's what releases the gas. So we oftentimes don't think about the esophagus until there's a problem and we have a bloated animal. Of course, then we will go into the rumen, and that's where we'll spend quite a bit of time talking about this evening. That is a 40 to 50 gallon muscular container, and it is anaerobic, meaning there is no air in the rumen. The bugs, as we'll talk about throughout this, or they don't survive in the presence of air. So it is an anaerobic environment, and that is a very large, smooth muscle, which means the rumen is involuntary contractions. And so that large muscle continually churns the food that the cow consumes and makes it available for those microbes to ferment. You maybe have heard of the honeycomb, and that's what's shown here as bottom right of your screen. That's the reticulum, a picture of the reticulum. If you've ever heard of a honeycomb tripe, maybe seen that or consumed that yourself, that is actually what you're consuming when you eat menudo in South Texas. So that's the reticulum, and that is where hardware and foreign objects are kept or caught. You can also see that where that is located on the animal, it is not infeasible. And I have had a veterinarian diagnose this one time where an animal consumed a relatively large nail. That nail poked through the reticulum and went into the heart and killed that particular cow. And so you can see where that reticulum is, how that could happen relative to where the heart is on the animal. The next compartment is the omasum. Okay, and so this is the nickname for this particular part of the stomach is called the mini plies, and you can see again why it might get that name from the far right there. Here, the object of the omasum is when feed particles get to a small enough size, they pass through the roux, and the roux is ROO, and that's reticulo-omasal orifice. So a small hole that allows feed to pass through into the true stomach. As that feed goes through the omasum, those mini plies are squeezing out fluid and putting the fluid back into the rumen. From there, we go into the abomasum, which is the true stomach. So that's first poll question. That is the true stomach. What makes the true stomach is that's where we get the feed is acidified, and where protein digestion starts at this point. So from here on, really the digestive tract is very similar to yours, mine, pretty much any other livestock species. In the small intestine is where nutrient absorption occurs, primarily protein, fat, and of course minerals. And then the large intestine is where water is removed, where the waste is concentrated and expelled. There is some hindgut rumen fermentation in the cow, but obviously very small portion relative to the fermentation that happens in the rumen. In contrast, a horse or a rabbit would be more of hindgut fermenters and would derive some of their energy needs from hindgut fermentation. But that's pretty small contribution for the ruminant. At this point, I want to switch over and switch to a video that will kind of describe where we'll go with our next segment and talk about those rumen microbes that are in the rumen.
Greatness on the outside is bullness on the inside. What is the greatness happening on the inside of your cows? Have you ever considered the science behind how feed is digested? It's all about the bugs. It all starts with the microbes, or bugs, inside of the cow's rumen. These microbes include protozoa, bacteria, and fungi. They add up to more than a quadrillion rumen microbes per cow. Now that's a lot of bugs. Each type of microbe plays a critical role. Let's break it down further. Bacteria carry out most of the digestion of sugars, starch, fiber, and protein for the cow. Protozoa swallow and digest bacteria, starch granules, and fiber. And fungi open up plant fibers to make them more easily digestible. It might be hard to digest what these roles actually mean, but it's pretty simple. Cows don't have the enzymes to digest the fiber they eat. So, rumen microbes work together to turn forage into energy and protein that cows can use. These bugs are needed to digest feed and produce volatile fatty acids, or VFAs, which are used by the cow as energy. This energy is used for maintenance, growth, lactation, and reproduction, making these tiny bugs a very big deal.
Video from live from co-op.
All right, so from the video there, we'll go back and talk about a few of the things we heard. And so talked about the microbes, the bacteria, fungi, and protozoa. And as you will see shortly why we call them, I just shorten those the word microbe to bugs, and I'll show you why we say that here in a minute. But those microbes require some certain things for them to thrive inside the rumen. Carbohydrates, so fiber and starch. And when I say fiber, just think about cellulose, okay? So the cow, you, I, a pig, rabbit, we don't have the enzymes to digest cellulose, but those rumen microbes do. They also need a nitrogen source. So those rumen microbes are going to take the energy from carbohydrates, put it with nitrogen, and make bacterial protein so that they can grow and divide. And that bacterial protein will actually become the predominant protein source for the cows. The bugs themselves are about 65% protein. So as they flow into the small intestine, they are going to provide the predominant source of protein for the cow. Now you notice under nitrogen source, it says ammonia, urea, and natural protein. You may not have thought about this, but whether you feed a supplement with urea or not, that cow actually has urea in her system. It's one of the things that makes a ruminant remarkable, is that cows can survive on very, very low protein diets if they have to, because when they can recycle urea in their system. So at times of excess protein, they'll store that in the form of urea that circulates through the blood into the saliva. So when a cow chews her cud, there is urea in that saliva she's swallowing, putting back into the rumen to feed the bugs. That is then absorbed back through the rumen wall into the blood, and so continually recycle that urea. So there is actually urea in your cows, whether you feed a urea-containing protein source or not. And then these microbes are also living creatures, of course, so they need minerals just like any other living organism. So they need all of those things. With that, those microbes will take starch, fiber, and protein, and they'll produce volatile fatty acids. And they're listed there: acetate, butyrate, and propionate. There's one thing listed there that, or not listed there, I should say, that is worth mentioning, and that's the gas that is released when a cow belches and when she's chewing her cud. And of course, that gas is the one that we take some grief for in the animal livestock business. And that, of course, that gas is methane, very potent greenhouse gas. However, as we think about livestock production in the U.S., animal production accounts for less than 3.5% of the greenhouse gas production in the U.S. And there are many ways we can reduce our footprint with greenhouse gases. And for example, one is feeding ionophores, which can reduce the amount of methane that's produced. And quite honestly, if you have more interest in studying about methane or how to counteract some of those arguments, go on to YouTube and University of California, Davis, and just Google UC Davis and methane. And what you find is that the methane that goes into the atmosphere from livestock production is within 10 years is back to CO2, which is used by the forages with photosynthesis to grow. Of course, the cow consumes the forage, produces the methane. So it really is a cycle of life and a relatively minor contributor to climate change. All right, so one of our other questions on Christie's poll at the beginning was about rumen papillae. And of course, more rumen papillae do increase better nutrient absorption. And here primarily from a nutrient standpoint, what we're talking about absorbing are those volatile fatty acids. Those are the acids that are going to be absorbed across that rumen wall into the bloodstream, carried to the liver, and be the precursor of glucose and producing energy. So depending on when you went to school, they may have called that the tricarboxylic acid cycle or the Krebs cycle. But that's the cycle that's going to take those volatile fatty acids and produce glucose that's going to provide energy to the cattle. The papillae are those finger-like projections. Some people compare that to a shag carpet. If you think about that, but they line the inside of that rumen wall to increase surface area and thereby improve the absorption of those volatile fatty acids. So we've talked quite a bit about these bugs. So I want to show a video that will kind of describe why we call them bugs and give you a little bit of a feel for what is inside that rumen. So here, what you're seeing is under the microscope, one drop of rumen fluid that was placed on a slide, cover slip over that, and what you're actually watching at 100 magnification at this point is primarily protozoa. Okay, there's a big one that goes through there, and you can see why we call them bugs. They just are little bug-looking things that flit across the screen. They move by cilia on the side of their bodies that move them through the rumen fluid as they scour for feed particles to digest, looking for that urea, et cetera, so that they can reproduce as well. The things that aren't moving in there are large feed particles. Okay, and then some of the flow you see is just the flow of the rumen fluid. We'd have to get up to about 1,000 magnification to start seeing some of the bacteria in the slide. So the video talked about a quadrillion of those rumen microbes. The other thing that's very interesting and again makes this just a remarkable species is this rumen is turned over about 2.5 times a day. So total rumen volume turned over 2.5 times a day, and you've got a quadrillion bugs. So start doing the math. It really is remarkable with how this animal can digest forage and produce beef. At this point, I am going to go back to our video and talk a little bit more about how we feed these bugs.
But rumen microbes don't thrive on their own. The nutrition you provide cows can help maintain an optimal rumen pH, which helps microbes flourish. An ideal rumen pH also helps cows have optimal digestion. Let's look at what can happen in ideal and less than ideal rumen conditions. In a healthy rumen, the stomach has a good population of microbes, and those microbes are active. Microbes perform their best when there's a consistent supply of nutrition, which maintains a consistent rumen pH. When nutrition doesn't supply the nutrients needed for the microbe population to thrive, microbes become less active and less efficient if they function at all. This can happen with abrupt diet changes, inconsistent nutrition, and drops in rumen pH. The bottom line is, what and how you feed your cows affects which microbes grow, how the feed is utilized, and the nutrients available to the cow. One way to bridge the gap and provide the nutrients microbes.
All right, you got to wait a few minutes to get the exciting conclusion on that video there, and I wish I could draw as fast as that guy can. So we'll go back here to the slides and talk a little bit about that pH. So another of the poll questions was which rumen microbes prefer pHs above 6.2, and of course that is the fiber digesting. Starch digesting are active at lower pHs. Just to remind us, pH is a 0 to 14 logarithmic scale. 7 is neutral. So 6.2 is just slightly acidic. And of course, the rumen environment will be acidic because remember, the bugs are producing volatile fatty acids. In a feedlot diet where there is more starch present, we'll see lower rumen pHs in that 5.5 to 5.6 range. Okay, so what does all that mean? Well, sometimes when we supplement cows and we go out there with a high energy supplement, we can lower that rumen pH by putting a lot of energy into that rumen at one time. And so that's what is illustrated here. This is some older University of Wisconsin data. And what they did is they fed these cows at 0 hours, and you see within 2 hours they've dropped below that pH level that the fiber digesting bugs like. And then it's quite a few hours out here, 9 hours later, until that pH in the rumen is back above 6.2. And guess what? In this case, they fed them again, dropped that rumen pH. So the whole time that rumen pH is below the 6.2, those fiber digesting bugs are active, but they aren't as active and aren't as efficient as they could be if the rumen pH was above 6.2. What the green line shows is when rather than twice a day feeding, they fed those animals 6 times a day and thereby kept the rumen pH above 6.2. Okay, so keep that in mind, and I want you to remember that that 6 times a day, as we'll come back to that. Okay, so here's an experiment that was conducted at the Gray Summit at the Purina Animal Nutrition Center, where animals were provided access to hay, and just hay alone, and they ate 12.8 pounds. From there, we supplemented those cows. And when I say supplement, I use that term loosely because these were fistulated animals. Okay, so a fistula is the hole that is surgically put into the left side of an animal. And then a cannula is the actual rumen stopper, essentially, that closes that hole. And those animals are used in research so we can collect rumen fluid samples and conduct research on the rumen environment. So when I say supplement in this experiment, what actually happened is we popped the plug on the side of that animal and put in 3 pounds of a liquid feed that the Purina manufacturers called AccuRation Liquid. And what you'll see is we only fed those cattle 3 pounds 1 time a day. Forage intake really didn't change. Okay, the cattle still consumed about 12 pounds. However, if we pop that plug 3 times and each time we only put in 1 pound, forage intake went up. So what we actually did there was provide the rumen a more steady environment, provided those bugs feed when they need it and not slugs at one time, but several small amounts throughout the day. And by doing so, we dramatically increased the amount of energy that went into the cattle, basically 16% more based on how we fed the supplement by taking care of that rumen environment and feeding those bugs appropriately. All right, so here's one that's real world to you in Northwest Arkansas, Eastern Oklahoma, Southwest Missouri, whatever part of the world you were in. So you've probably been around like a cooked tub, like a Rangeland 3013 type tub. Okay, so here's the real world for you, what that means. Okay, so cow consuming 5.7% crude protein forage. If that's all she got, that cow could eat 21 pounds and she got 10.3 pounds of TDN. Okay, what's TDN? Total digestible nutrients. Think of that in terms of calories. Okay, just think of that as calories. So she got 10 pounds of calories. When she was fed a 14% grain mix, okay, so this would be like a 5-way mix or a 3-way commodity blend, something like that. Fed 3 pounds, what happened to forage intake? It actually went down. What happened? Because we only fed that grain mix one time, it dropped the rumen pH. The fiber digesting bugs weren't as active and as efficient. And so their forage intake actually went down. Did we get more energy into the cow? More calories? Sure we did, because the supplement is higher energy than the forage. But what if we fed a cooked tub? Okay, so now that cow only actually consumed 1 pound, but you've never seen a cow try to chomp off 1 pound of a cooked tub, right? It's physically impossible. She has to come back several times a day to lick that tub to get a pound. Again, she is just feeding those rumen bugs continuously throughout the day. And what happens? Dramatically increased her forage intake and a 30% increase in this case of calories that were delivered to that cow simply by how we fed those rumen bugs and got more of that forage through them. Okay, here's another example. This is one I deal with quite a bit. As Christy mentioned, I'm in North Missouri. We have a lot of corn up here. We're going to have a whole lot of corn this fall. And sometimes people say, I feed more corn and my cows get thinner. What's going on? Well, here's what happens. At the bottom, it shows the pounds of corn supplement and what happened to forage intake as corn intake went up. And so I want to do some really quick math with you. Okay, so everybody get your pencil and paper ready, all right? And we're going to say that hay is 50% TDN, 50% calories. Corn is 70%. So if all they got is 19 pounds of hay that's 50% TDN, they got 9.5 calories, right? Okay, everybody with me? We go to 18 pounds, which is what the forage intake was when we fed 2 pounds of corn. So we had 9 pounds of energy from the hay, 1.4 from the corn, so we're at 10.4. So we got more energy into that cow. We think, oh, she's still losing a little weight. I'm going to bump up the amount of corn. Okay, so I go to 4 pounds. So now she gets 7 pounds of energy from the forage and 2.8. So she's at 10.8. 10.8 here versus 10.4 here. Basically, I wasted 2 pounds of corn because I didn't get significantly more energy into my cow. Say, my gosh, 4 pounds didn't work. I better go to 6. Okay, so now what happens? 11 pounds of hay, that's 5.5 pounds of TDN. The corn delivers 4.2 for a total of 9.7. So now I fed her 6 pounds of corn and she got 1 pound less energy. How in the world did that happen? And it's all because we slug fed that rumen with a lot of starch, decreased the rumen pH, the fiber bugs didn't work, therefore the cow couldn't consume more forage. However, remember I said, remember that 6 times a day thing. What if we fed this 6 pounds of corn rather than just once, but at 1 pound 6 times a day? You say, well, Crosby, nobody has the time to go do that. I agree. We don't. And so what are some of the technologies we can do to implement that will allow us to feed our cows 6 times a day, but in small amounts, so that now we can better feed those bugs? And so that's how we'll wrap up by showing, going back to this video.
Need to flourish is providing your cows with Purina AccuRation supplement, available in block, tub, liquid, and meal forms. It helps provide the consistent nutrition needed to achieve a desirable rumen environment and maintain a consistent body condition score. A consistent body condition score can lead to cows breeding back quickly, optimize conception rates, and calf weaning weights. Next time you think about your herd's nutrition, Think from the inside out. It's all about the bugs. Think about feeding rumen microbes, which fuel digestion, nutrient utilization, and ultimately a productive cow. That's greatness you can see. Purina Accuration with intake modifying technology is one of many proven flexible solutions available through the Purina All Seasons Cattle Nutrition Program. The program covers every life stage and every season. Unlock the greatest potential of your cattle from the inside out. Feed greatness. Greatness on the outside is born.
Okay, so what we can't physically go out and feed our cows 1 pound 6 times a day. Just nobody has that time. So what the Accuration and our IMTech products allow us to do is to do that. And how do we know that we can get that done? This is just a few brief pictures to show you from our Animal Nutrition Center at Gray Summit, Missouri. So what you see here are pictures of the fistulated steers. So you can't really see very well, but there just on the side of that one, you can kind of see where that cannula is on the left side of the animal. So we can collect rumen fluid and see how we affect the bugs based on how we feed the animals. You might ask, why do we use Holsteins? Well, because they're easy, gentle, and get along well with and don't cause us a lot of problems. And the rumen bugs in Holstein are like beef cattle, just depend on what we feed them. So it doesn't really matter on the breed. Can we affect how cattle consume feed? And we can. And so this is just an illustration of some ways we do that and how we test it. So this is in a picture of what we call Barn 1. Very innovative name there, you might say. But around that animal's neck is a transponder. So it can only get in this gate. And so we know exactly how much that animal eats. 291 over here can only get in this gate. So we know exactly how much 291 eats. But what makes Purina unique in what they did is see this cord goes through here. It goes up to these scale heads where now we know how much 291 ate. But not only that, but we know how many times 291 came up to consume feed, the biggest meal, smallest meal, etc. So we know whether we change their eating pattern. We can do the same thing out on pasture with this unit. Basically, think of a self-feeder. And that's what that is, except now we know which animal comes up, how frequently, and how much they consume for each meal. With that type of equipment and facilities, we can gather this type of information. So, for example, this was with an Accuration range supplement product where the cattle on this particular experiment ate 4.6 pounds per day, but they ate it over 3.5 times. So obviously the average snack is about 1.5 pounds each time they came up to consume. The largest snack, which is typically in the morning, was about 2.5 pounds. So that is how we know we can utilize some of our technologies to change the way cattle consume feed, to enhance the rumen microbial population, better feed those bugs so we can maintain the cow and the bug performance despite changing forage conditions. This is what we call all seasons nutrition, and you'll be hearing more about that through our cattle chat series. And with that, I am going to stop and would love to answer any questions that have come through.
Dr. Crosby, we had a question that came up in our chat box on, got a couple of them that came in on our Facebook stream tonight. One of those, Cole asked, does water intake affect rumen microbes?
Water intake is huge. That is a 40 to 55 gallon, basically 55 gallon drum is the rumen, and they do have to have a lot of water. And one of the classic experiments, I think, was done at Texas A&M a number of years ago, where they looked at dehydration of cattle shipped during transit. So you wean your calves, you put them on a truck and maybe ship them 10, 12 hours to a feed yard. And so those cattle are dehydrated. And when looking at the rumen microbial population, it was dramatic in terms of the population, the species that were still present. And that's part of what takes so long when cattle are under stress and maybe don't drink, to get them back on feed. Part of what is involved in shipping stress is getting that rumen working again, because certainly dehydration, not enough water, and and quality of water to some degree can affect those rumen microbial populations. Good question.
Great. So then we got another one that dropped in our Zoom chat room tonight. Does mineral affect rumen efficacy?
It does. All minerals are important, not only for the cow, but certainly for those rumen microbes as well. As we talked about, they are living creatures. They have a mineral requirement, just like you and I. There's some dairy work showing that as well, specifically with phosphorus. And then there's a classic University of Missouri data set I did not include tonight. It was one of the final slides I pulled out in the interest of time, but it showed fiber digestion, or forage intake and forage digestibility, when cows were fed a protein supplement, an energy supplement, or a mineral supplement. And when they were fed all three is when they got the highest best improvement in forage intake and digestibility. So certainly minerals are important for those rumen bugs as well.
Perfect. And then we've got another one that came in off of the Facebook feed from Greg. Is how important is bicarbonate in a feeder calf ration?
Okay, so sodium bicarbonate would be termed a buffer. So something that we might use to raise the rumen pH if an animal gets to an acidic pH environment. Quite honestly, in beef cattle production, we rarely see a value in buffers, and part of the reason is we're either on a forage diet or we're on a feedlot diet. We're not in between there very much, and so on a forage diet we don't need it, and on a feedlot diet where that pH is in that 5.4, 5.5 range, actually bicarbonate is not a very effective buffer at that lower pH. Where buffers are used and where it makes sense is actually in dairy production. If we think about a dairy diet, those animals are fed, I always kid my dairy nutritionist counterparts, the least efficient diet, because it's basically 50% forage, 50% energy. And in those pHs in that 5.8 range, 5.9, 5.6 range, buffers are effective and can keep that pH from dropping even farther. So buffers are used quite a bit, especially bicarbonate in dairy rations. Not quite as important in our cattle diets.
Perfect. So we've got another one that dropped in from Miss Yvonne in our Zoom chat box. Is how do the bugs react to antibiotics?
Okay, they do. So it's for example, let's talk about ionophores. So some ionophores are antibiotics, and when we think about antibiotic, what's that word actually mean? Anti is against, bio or biota is life, so they are against life. So they are going to change things. So, for example, we use ionophores as a means to improve efficiency, and so what they do is they prefer a certain gram. They affect gram positive bacteria, which are more of the acetate producers. What that allows the other bug populations to grow in the rumen, which are more propionate producers. So that's a more efficient capture of energy with less methane reduced. So in that case, antibiotics, in the case of an ionophore, work very well for us. In the terms of long-term feeding of antibiotics, for example, of animals, let's use an example like a chlorotetracycline or aureomycin in cattle for anaplasmosis protection. So aureomycin, we need that. We feed it through a mineral program or something like that, maybe for anaplasmosis prevention. And with that, see very, very limited effect on those bacteria. So it kind of depends on the antibiotic, the high level or low level we feed, length of time, But certainly I'd have to say that in most cases, antibiotics are going to affect those bug populations, either in the rumen or maybe more importantly in the small intestine.
Perfect. So we've got another question that dropped in on our Zoom chat. What is the biggest component in nutrition that is overlooked?
Biggest component in nutrition that's overlooked, I'm going to say it's water. Okay, so we had that question early on about how important it is for that rumen to have the right hydration level, but for our cows, if they can have the best feed in the world, but if they don't have enough water, they're not able to consume it. The rule of thumb is for every 1 pound of dry matter that an animal needs, they need 4 pounds of water. So a cow eating 30 pounds of dry matter a day, she needs, without any heat stress, 240 pounds of water. So, that's 30 gallon of water a day. And in South Arkansas in August, she probably needs about half again that much. So water is the underlooked thing. And you all have probably heard stories of cows that walk past the pond to get to the rural water. There's a reason. They prefer good water. And in drought times when they're standing out there in some of those ponds, I'd say that water quality is probably affecting rumen efficiency and certainly intake of the cows as well, because they're not drinking as much water as they need.
So got a question that came across on my cell phone this evening from Trevor. And his question is how long does it take to switch the microbe population when changing those diets? So thinking about weaning time.
Absolutely. Yeah, great question. And the answer to that is it takes a minimum of 2, and I prefer to do it over about a 3-week period. So it takes just an adaptation period as we slowly increase the energy, decrease the fiber component of the diet, and move the bug population over. If we do that too quickly, what happens is we don't have enough bugs in the rumen to utilize some of those other acids that are produced, one of which is lactic acid. So one of the analogies one of my coworkers used is if you've ever overexerted yourself and maybe run more than you needed to or worked harder than you need to and your muscles are stiff, that's an accumulation of lactic acid. And lactic acid can accumulate in the rumen as well, get into that smooth muscle rumen wall and stop contracting. And that's a bad day when that happens. And so we slowly adapt those rumen bugs, increase the amount of lactic acid utilizers in that rumen to keep that from happening. And so that takes about 3 weeks as we change that population. So if you're send cattle to the feed yard, they're going to take somewhere 2 to 3 weeks to get those cattle worked up on full feed.
Perfect. Well, I'm going to check our Facebook stream one more time to see if we've got anything I might have overlooked. But at this time, Dr. NT, it looks like that's it. So I'm going to kind of take over the screen share here to let them know a little bit more information about how they can go on their cell phone and become eligible to receive a $10 off coupon tonight. So with that being said, if you guys got any last questions, feel free to drop those in as we're going to continue to monitor our chat. But if you pull out your cell phone and you text 95323, and in that body type in Purina, you will receive a text message right back that will provide you a hyperlink. You click on that hyperlink. It will ask you to enter in an email address, and then it will pop you into another screen, which you would want to select A for Arkansas, as the Farmers Co-op location. Corporate office is located in Van Buren, Arkansas. Select Arkansas, and then for tonight's coupon, we would be selecting the $10 off Farmers Cooperative Checkerboard Days. With that being said, is this coupon registration is accessible for 2 days. So that would end on the 6th, which would be on Thursday. So what will happen in roughly about 5 minutes, you will receive an email. It will come from noreply@digigraph.me. It will provide you a little personalized digigraph, as you can see here, with a link to click on the $10 off. And then you can print off your $10 off coupon and take that into your local farmers co-op location. So just kind of wanted to go through some of the virtual meetings that we have on schedule for August of 2020. NT and I enjoy getting out and about and visiting with folks and having meetings face to face, but your health is just as it's a huge importance for us. So we decided to take things into a virtual platform, trying to set these up in 20 to 30 minute little chat times. So on Tuesday, August the 18th at 7 o'clock, Dr. Elizabeth Backus-Blue will be joining us to talk about creep feeding. That would be our next cattle meeting. Then if you have interest for equine, on August the 13th at 7 p.m., so that will be next Thursday, our Purina equine specialist, Ty Cunningham, will be joining onto the platform to talk about how do we read that feed tag and how Purina uses constant formulation with our diet. And then at the end of the month, on August the 27th, Dr. Michael Slagle will be joining us to talking about feeding strategies for our aquacultures. So feeding those fish that are in our ponds. So all of our virtual meetings are located on the Farmers Co-op website. You go on there, you can click to register for everything. What we have set up is our cattle online meetings will be every other Tuesday at 7 o'clock. And then the off week on Thursdays will be either an equine meeting or aquaculture or a wildlife. If you register and attend the Zoom, we'll put your name in the hat to win one of two $25 Farmers Co-op gift cards. And of course, we will be streaming these as well onto the Farmers Co-op Facebook page. So with that being said, we're going to probably do a little bit of last call for questions at this point. Couple of things I think about is we at Purina do offer some opportunities to feed the Purina greatness. You stop by any of your local farmers cooperative locations. There's 15 of those in Western Arkansas and Eastern Oklahoma. We've got little feed greatness trials for cattle and horses and our backyard flock, show animals, backyard swine. So swing by. Any of your staff members at the Farmers Co-op will be able to answer any questions about that. So I'm going to do one last check. I'm not finding any other questions floating around, but I do want to provide the number again for your $10 off coupon. And that is if you text Purina to 95323, you will receive a hyperlink to be able to select for the $10 off coupon. So once again, you would select Arkansas, $10 off Farmers Co-op Checkerboard Days, and that coupon is accessible for 2 days, which will end on August the 6th. So with that being said, do one last check on the cell phone and in our chat room and on Facebook. NT, I don't see anything else at this time. We appreciate you joining on, and you'll be back on our program in September. Is that correct?
I will, talking about weaning feeds.
Perfect. So wait, I got one flashing here, so I guess I talked too soon. So Yvonne is, hang on a minute. So during
weaning, I think.
weaning is yep. I think that would be weaning.
We have hay along with feed, and depends on which weaning program we're using. The one if we're feeding less than 3% of body weight from our feeds, we would have to have forage available. So, for example, the tried and true Purina weaning feed is Purina preconditioning, receiving, chow, or pre-con complete. It's kind of there on the middle of your screen underneath the lick tank there. That one is typically fed at 10 pounds per day. So the cattle are going to have something else. So what works well with pre-con is some long stem hay, stimulate that rumen, provide some scratch, get them chewing their cud. And that's so important for ruminant animal all the time, but especially during the weaning period, keep them healthy. We just don't have sick calves when we can get them chewing their cud. So hay is part of several of the Purina starter programs, but it kind of depends on which one you're using.
So NT just came across is, so when we think about weaning, we think about the Purina weaning programs that we do offer, the stress care versus the pre-con. Is there a weight bracket that we would recommend one over another?
With the Stress Care 5 is a 5-pound fed rate product. It works better for calves that are 450 pounds and heavier. And the reason is you've got an early wean calf, maybe a first calf, heifer's calf that's 300 pounds, and we try and get 5 pounds into them. And that calf has got such a small rumen that when we fill it up with 5 pounds of feed, there's not much room for a whole lot else. And so in that case, a product like Pre-Con that has some roughage built into that pellet would be a little bit better for those lighter calves. So a Stress Care 5, more for 450 pound calves. On Pre-Con will work pretty well on any weight of calf, but a little bit better on those lighter ones.
Okay. Perfect. Well, excellent. Once again, we appreciate you taking the time this evening to join us, and we look forward to seeing everybody back on the platform. I think we'll just hang out just for a second to make sure we don't have any other final questions. Jennifer, do you have any closing remarks that you would like to make on behalf of the co-op tonight?
Absolutely. On behalf of not just Waldron Co-op, but all of our co-ops in our system, thank you guys for joining in. Come see us at the stores. If we can't answer your questions, we can always get a hold of Christy, but we'll be glad to help you guys in any way that we can.
All right, guys. So appreciate everybody. We'll catch you guys here in 2 weeks on our next cattle chat.
Thank you all.
Thanks, guys.
Good night.